tomorrow is the test. And for some of you, it's a really big test.
PCA and AB got tests tomorrow.
Only 3 questions? I find it hard to believe. Now is the time to ask. Because we got the whole period, you got a whole range of basic various stuff. Put 911 if you have to. Okay. Somebody steal my somebody stole my worksheets. Oh, what a big difference. Alrighty then. Are they here? No, I don't know where they are. Okay, somebody's just gonna have to read me the problems then. No, just take it out of the work. Alright. Oh, there they are. Okay, so let's see. Vector 6. Number 1. Okay, did you guys draw a picture? Okay, here is a cube. Doop, 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 doo-doo-doo-doo-doo, doo-doo-doo-doo-doo, doo-doo-doo-doo-doo. Find the angle. Okay, I'm reading this. Angle. What are you thinking when you see find angle? Skip to the next problem. No, dot product. Anytime you have to find an angle, you're going to use the dot product, okay? That the diagonal makes it one of which has, okay, a diagonal goes from here to the opposite corner, right? This is the diagonal. And find the angle that makes it one of the edges. So you got 3 edges, like right here. You got this edge, that one, and this one. All the angles are the same, right? Because it's a cube, right? So you have to find this angle here then. So how do you do that? You're going to use the dot product. So what you need to do is you need to componentize these 2 vectors here. Because those 2 vectors form that angle. Okay, probably the easiest thing to do is set up a coordinate system. So why don't we make this the origin? This is the origin. This is the x-axis, the y, and the z. So wouldn't this be the point 1, 0, 0? And of course, this is the origin, duh. And if this is a cube, wouldn't that be 1, 1, 1? This point over here, 1, 1, 1. Right. So how do you componentize this vector? Head minus tail. 1, 0, 0. How do you componentize this vector? Head minus tail. 1, 1, 1. And then just do the dot product thingy. So the cosine of this angle is equal to the dot product. You multiply the x components, you multiply the y, you multiply the z, and you add them together. Divided by the length of this vector, which is the square root of that squared plus that squared plus that squared, which is 1. And then the length of this vector is the square root of that squared plus that squared plus that squared, which is root 3. So you get 1 over root 3. So therefore the angle is cosine inverse 1 over root 3. And since that's not a number we know, just leave it like that. But then tomorrow, if it comes out cosine inverse 1/2, then you better put pi over 3 or 60 degrees, right? Okay. Why, or were you confused with the answer that I wrote on the bottom? Was that the confusing part? No. Just, okay, for some of you don't even know because this is the first time you're looking at the problem. Look, cosine inverse 1 over root 3 means adjacent over hypotenuse is 1 over root 3. If you use the Pythagorean theorem, wouldn't this be root 2? So isn't that also the same thing as tan inverse root 2? This is on the bottom. But it doesn't matter. There's 6 ways of writing that angle, right? You can write cosecant inverse root 3 over root 2, right? But just leave it like this tomorrow and nobody will get hurt. Okay. Number 2. You guys, unbelievable. You guys gonna do the easy ones, but then the hard one, number 3, you can do. That is amazing, period 3. Because number 3 is the one you need for tomorrow. Number 2, write the equation of the sphere with center. Okay, you know the center of the sphere. That means you can write almost the whole equation already. X minus 2 squared plus y minus 3 squared plus z minus 5 squared equals the radius squared, right? If you just know the radius, the problem's done already. And it is tangent to the plane. Okay, so here you have a sphere. You know the center. Here's the plane that's tangent to it. And what's the equation of this plane? 3x plus 4y plus 5z minus 3 equals 0. How in the world am I going to find the radius of this sphere? The distance from a point to a plane, right? When we draw the radius to the point of tangency, it makes a right angle. And so you know how to find the distance between a point and a plane? You better know this tomorrow. You're going to use it multiple times. Okay, so here's the 2, 3, 5. And remember, when you write the equation of the plane, it has to be in general form, so you got to bring the 3 on this side. Okay, then just use the formula. Absolute value of 3 times 2 plus 4 times 3 plus 5 times 5. And please don't forget this formula because you're going to be using it next chapter 2. All over the square root of a squared plus b squared plus c squared. So 3 squared plus 4 squared plus 5 squared. You guys can crunch those numbers, right? Okay, you guys can take it from there. See how easy that was? That's just an appetizer. So we don't need to do number 3. You sure you guys don't want to do it? Because don't you do it? Okay, tomorrow this problem is going to be a problem. Like I'm going to describe a set of points in space. You have to write the equation. Okay, so write the equation of the set of points. Okay, so here, if you need to draw a picture, draw just a quick sketch. Okay, here's the point 0, 0, 1. Here's a representative point x, y, z. Okay, write the equation of the set of points that are equidistant from this point and the plane z equal negative 1. Now where is the plane z equal negative 1? Yeah, that's 1 unit below the xy plane, right? The equation of the xy plane is z equals 0, right? So z equal negative 1 is 1 floor below. See? So you got to go 1 floor down like that. So here. And we want these two distances to be equal. Now, tomorrow, if you be following, you got to write something down so you can get points on. How do you find the distance between here and here? Distance formula. Square root of x minus 0 squared plus y minus 0 squared plus z minus 1 squared. And that equals this distance. Now, how do I find the distance between a point and a plane? Do I need to use this formula here? No, not when the plane is like parallel to the xy plane. It's just, I keep showing you guys this. If this is 2 and this is 5, do I need an exotic formula to tell me that's 3? No. What do you do? Top minus bottom. This is, believe it or not, in calculus, this is super important, you know. Top minus bottom. Big minus small. That guarantees it's going to be positive. So what's the z coordinate up here? Z. What's the z coordinate down there? Since this is the plane z equal negative 1. Negative 1, so what's top minus bottom? Z minus negative 1. Right? Top minus bottom. And then what if it's this way? What do? You go right minus left. But the important point is you go big minus small. Actually, you could use this formula. You can get the same thing. Did anybody use this formula? Yeah, it came out to the same thing, right? That's because the equation of this plane is z equal negative 1. So that's like z plus 1 equals 0, right? So then a and b are 0, right? So it's going to be 0, 0. You're not going to have these two terms, right? So it's going to come out exactly the same. Anyway, that's it. And then, okay, so you get to this tomorrow. I'll give you 2 or 3 out of the 8 points. you want the rest, then you have to like simplify it, put it in standard form. Anyway, didn't this one come out to a paraboloid? Just think about it. What's the set of points in space that are equidistant from a point and a plane? Well, in 2 dimensions, what's the set of points that are equidistant from a point and a line? Parabola, right? So in space, if this was a plane instead, wouldn't it be a paraboloid? So yeah, so what you're writing here is you're writing the equation of a paraboloid. And you can probably guess that's the focus, right? Okay. And then number 5. Boo! Boo! Okay. Given, okay, so you got these 3 points in space. 3, 1. Do you guys recognize these numbers that I put in here? I have to pick out numbers, so these are just use whatever. These are the digits of pi. Come on, look, 3.14159.265. Whatever. Find the measurement of angle ABC. This angle right there. Okay, it says angle. What do I do? What am I going to do tomorrow when it says find the measurement of this angle? Yeah, componentize, but what tool are you going to use? It rhymes with hot. That's so sad. That's sad. Okay, so those 2 vectors form angle B. So we need to componentize vector BA and BC. So head minus tail. 2, -4, -5. And then again, head minus tail. So you go 1, 1, -4. Did I do that correctly? See, once the vectors are componentized already, come on. The cosine of the angle is equal to the dot product, so multiply the x components, multiply the y components, multiply the z components, add them together. All over the length of this vector, whoa! Root 45. And then the length of this vector is the square root of that squared plus that squared plus root 18. So that comes out to 18 over, this is 3 root 5. This is 3 root 2, but 9 goes into 18 2 times, so that comes out to 2 over root 10. So theta is equal to cosine inverse 2 over root 10. Just leave it like that, can't do anything with that. Okay, part B, find the measurement, find the area of this triangle. What's the fastest way to find the area? You can go 1/2 AB sine C, but you know what? Let's do the cross product way. That's probably what you're going to do tomorrow, yeah? So, how do you find the cross product of these 2 vectors right here? You make a determinant, I take k across the top, put in the components of the vector, 1, 1, -4, and then compute. Let's go across the first row. So it's going to be I times something minus j. Don't forget this minus one. So if you cross out the row and column, you get 16 plus 5, 21. -8 plus 5. And then 2 plus 4, 6. And like I said, if you don't like the IJK notation, change it back to this then, 3 root 6. This is the cross product of these 2 vectors, BA and BC. Half the length of that is the area of the triangle. So how do you find the length of this vector? You simply go square root of that squared plus that squared plus that squared divided by 2. That's the area of the triangle right there. Okay, this is one of the problems tomorrow. You just got to do it. You just got to execute. You guys can, of course, you got to simplify that though. Okay, then part C says, write the equation of the plane containing this triangle right here. What do you need to write an equation of a plane? A point, you got 3 points, and a vector that's perpendicular to it. Well, isn't the cross product perpendicular to the plane containing the vectors? So if this is the perpendicular vector, then what's the equation of the plane? 21x plus 3y plus 6z plus d equals 0. How do you figure out what d is? Plug in any one of these points. Which one looks the bestest to you? Tell me when to stop. Stop. Okay. Well, see, but look. Okay, never mind.
No, B.
Too late.
Do B.
No. See, got the big number there. That's why. No. I like to work with big numbers. Too late. Anyway, it come out the same. 63 plus 3 plus 24 plus d equals 0. So that means d equals negative. Oh boy. 90. So 21x plus 3y plus 6z minus 90 equals 0. Box that, that's the answer. Minus 1, because you can reduce by 3, right? Yeah, I think you guys can reduce by 3. Just make it. Okay, next, 6, 7. Okay, we've done this problem how many times? Is it like because you guys don't remember what you've done before? Okay, there's two ways of doing this. One is, okay, if you don't know anything, just componentize, because that's probably the simplest way to go every single time. Just componentize. Okay, you have two vectors, and when you put them tail to tail, they make a 120-degree angle. Vector A is 5. Okay, now, to me, the simplest way is put the tail at the origin and go like that. So this is 0, 0, and if the length of this vector is 5, wouldn't this be 5, comma 0? So when you componentize it, when you go head minus tail, wouldn't that just be 5, 0? See, when you put the tail at the origin, it's so easy to work with vectors. And it makes a 120-degree angle with vector B. Now the length of vector B is 3. This is 3. So in order to componentize this vector, I have to know the coordinates of this point up here. Well, if I know this angle is 120 degrees, and this is 3, how do I figure out the coordinates of that point up there? Well, isn't that like the same thing as polar coordinates? R tells you how far you are from the origin and the angle. Or whatever, I mean, do whatever. Just draw a right triangle and you got a 30, 60, 90 right there, right? I mean, whatever. Just do it. So, which way you want to do it? Polar. Okay, what's cosine of 120 degrees? Okay, let's do the other way. It's negative half times 3. Negative 3 halves. And sine of 120 degrees? Root 3 over 2 times 3. So 3 root 3 over 2. So this is vector B. So if to componentize it, you go head minus tail. So it's going to be negative 3 halves, 3 root 3 over 2. Now do exactly what it says to do. It says subtract. So vector A minus vector B. How do you subtract vectors if they're in component form? You subtract the x components. What's 5 minus negative 3 halves? Oh boy. 13 halves. And then what's 0 minus that? Negative that. And then what do these bars around it mean? What does that mean? That means the length. How do you find the length of a two-dimensional vector? It's the square root of that squared plus that squared. So what is that? 169 over 4 plus 27 over 4. And I can see that's going to simplify mighty nicely. You guys can take it from there, right? That's one way to do it. Did anybody do it just by drawing vectors? Law of cosines? One person. Look, if this is vector A and vector B is like this, well, what is vector A minus B? Because that's what we're doing, right? What is A minus B? Which way? If this is vector A minus B, which way does it point? Doesn't it point that way? Remember, this plus this equals that? Okay, look, let's call this box. Some of you going, what are you talking about? Let's call that box. So looking at this picture, isn't B plus box equal to A? I can't believe we're using box in honors. Therefore, box is equal to A minus B. Woo. So for those of you who haven't figured this out after studying all these vectors, if you have two vectors tail to tail, if you subtract them, basically it forms like the third side of the triangle. But you guys in physics, right? That's second nature, right? And then of course, if you know that this is 5 and this is 3 and that's 120 degrees, you can just use the law of cosines to figure out that side, right? But then you gotta know that A minus B is like the third side of the triangle though, but if you don't know that, then. Anyway, the simplest way is just componentize. That's the simplest way. Okay, number 7. It says find the angle. Oh, it says angle. What am I gonna do? It rhymes with zot zada. I can't do it anymore. 3, -3 root 2, -3. Okay, here's a vector. I put it in IJK notation, but a lot of you don't like it, so you write it like that. Find the angle that this vector makes with the positive z-axis when you put the tail of V at the origin. Look. Okay, here, let's draw a picture. X, Y, Z. Okay, here's vector V. Okay, I know it doesn't point, it points like somewhere else, but let's just say it points like this. Here's vector V. Find the angle that it makes with the positive z-axis like that. Find this angle. Now, in order to use the dot product, okay, you need to have these two vectors componentized. Well, this one is. What about this vector? How do you componentize a vector that points like in the positive z direction like that? Well, there's an infinite number of them. Just you come up with one of them. 0, 0, 1. Or how about 0, 0, 2, or 0, 0, 3, or 0, 0, 10, or 0, 0, 100? Yeah, any of those will work. It doesn't matter. But think about it, because look, if this is 0, 0, 0, the origin, and this point is on the z-axis, wouldn't the coordinates be like 0, 0, 3 then? So how do you componentize it if you go head minus tail? Isn't it going to be 0, 0, something? It's just easier to use 1, but you don't have to use 1. You can go 0, 0, 17 if you want. Okay, now, once you have these two vectors componentized, how do you find the angle again? The dot product. Cosine of the angle is equal to the dot product, which is 0 plus 0 minus 3, all over the length of this vector, which is the square root of that squared plus that squared plus that squared. Oh my, 1. And the length of this vector, which is the square root of that squared plus that squared plus that squared. What's the square root of 9 plus 18 plus 9? Which is 6. Oh, so this comes out to -half. So theta is equal to, that's a number we're supposed to know for cosine. 2 pi over 3, it's 120 degrees. Okay, so look, anytime it says angle, I'm using dot product. What are you gonna do tomorrow? We'll see, yeah. Okay, very good. Number 8, everybody can draw the box. Is everybody drawing the box when you convert from one to another? Okay, we're ready then for tomorrow's one then. Number 9. No, this is mechanical. Okay, vector A is this. Vector B is equal to this. You wish you get a problem like this tomorrow. This one is no thinking. Find vector D now. Do we know what the components of vector D are? No, so what do you want to call them? A, B, C? Okay, good choice. Okay, so it says vector A dotted with D is equal to 11. How do you dot vector A and D? How do you find dot product? You multiply the x components, you multiply the y components, you multiply the z components, and you add them up. That's how you find the dot product. And then it says that's got to equal 11. Can you see where we're going? Keep going. B dot D. So if I dot these two vectors, you're going to get 8. So how do you find the dot product? You multiply the x, you multiply the y, you but that is the components, and then you set that equal to E. And then the dot product of these two vectors, it says is equal to -3, so dot product A plus B minus 3C, you forgot the number already, where are we go, -3. And then just solve 3 equations, 3 variables, right, you guys should be experts at that. I don't care how you solve these 3 equations, 3 variables. If I were me, I would eliminate B, because look, if you just add these 2 equations, the B's drop out. But it's up to you. Or some of you want to use Kramer's rule. No, I don't think so. Oh boy. And then number 12. What? 2 vectors of lengths 8 and 10 form an angle of 2 arctan 1/3. That's an angle measurement now. Find their dot product. Okay, what's the definition of the dot product again? The length of the first vector times the length of the second vector times the cosine of the angle, right? Just like work. In fact, I just said, you guys watch Big Bang Theory? They just talked about work. I was watching it last night, something about foot pounds. What's that? Okay, anyway, now, so this problem just boils down to this. How do you compute the cosine of 2 times this angle? This is something we've done before, yeah? Is arctan 1/3 a number, an angle we know off the top of our heads? No. So how do you do this kind of problem? You draw the picture. Arctan 1/3 would mean opposite over adjacent is 1/3, and then you Pythagoreize. So how do I find the cosine of 2 times this angle? Should I just take the cosine of it and times it by 2? Or should I use identities? Yes, this is cosine of 2 theta. There are 3 identities. My favorite is cosine squared minus sine squared. I don't know which one yours is. So now you look at the picture. Cosine theta is adjacent over hypotenuse, so 3/√10 squared. Minus sine theta is 1/√10 squared. So that comes out to 9/10 minus 1/10, which is 8/10, which is 4/5. So the answer is 8 times 10 times 4/5. You can take it from there. Because 4/5 of 10 is 8, 8 times 8. Why don't I just finish it, 64. There you go, that's the answer. So the problem is basically computing this, right? Draw a triangle and use identities. And then the B, find the magnitude of the cross product. How do you find the length of the cross product? What was the definition of that? The length of the first vector times the length of the second vector times the sine of the angle. Okay, think of that as theta. So again, you got sine 2 theta. You got to use identity. 2 sine theta, cosine theta, and then you look at the triangle. So 2 sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, so that comes out to 6/10, which can be reduced to 3/5. So the answer is going to be 8 times 10 times 3/5. Okay, this one you guys take it, yeah? Okay, I'll do it. 3/5 times 10 is 6. 6 times 8, 48. So basically that was a trigonometry review. That's what that was. And this is like solving an algebra review. See how I sneak it in? And then 13, this is to separate the sheep from the goats. Not really. This is to see if you remember the right-hand rule, basically. What's that? X, Y. Given A and B in the XY plane as shown like this. Here's vector A, here's vector B. It forms a 120-degree angle like this. The length of vector A is 3, the length of vector B is 4. Find A cross B. Now, if you want to, you can componentize these vectors, but that's not really what I want. What is the cross product of 2 vectors? What happens when you cross product 2 vectors? You get, what do you get? You get a number, or do you get another vector? You get another vector, people. dot product, you get a number. The cross product is another vector. And so if the answer is going to be a vector, you not only have to give the length of it, you have to give the direction of it. Okay, so let's do the length of it first. How do you find the length of the cross product? Well, we kind of did it right there in column B, right? It's the length of the first vector, which is what? Somebody give me the numbers. 3 and 4. The length of vector A is 3. The length of vector B is 4. And then the sine of the angle, which is 120 degrees. What's the sine of 120 degrees? Root 3 over 2. So that simplifies to 6 root 3. So if I dot product these two vectors, you're going to get another vector. The length of that vector is 6 root 3, but now you got to state the direction of it. How do you figure out the direction? You use the right-hand rule. So since A comes first, what's the shortest way to go from A to B? Clockwise, right? So if you curl your fingers clockwise like this, which way is your thumb pointing? That way. Or remember the screwdriver way? If you turn the screwdriver clockwise, the screw goes in. So somehow you have to indicate the direction. So you could, so if you wanted to draw it on your paper, you could do that, right? Remember? But you have to somehow indicate the direction. So you could draw me a picture, or you could tell me in words. The vector is 6 root 3 units long, pointing that way. Now, what is that way? This is the xy plane, people. And here's the z-axis coming out like this. What direction is that way? That's the negative z direction. So you could just say it in words. The vector is 6 root 3 units long, and it's pointing in the negative z direction. Or you could give, like I gave, components. If you want to give it in component form, wouldn't it be 0, 0, negative 6 root 3? Because look, if a vector is pointing that way, it doesn't have any x component, it doesn't have any y component, but the z component is negative 6 root 3. Oh boy. Okay, anyway, so the cross product is a vector. So you have to give the length and the direction. So you can either describe it in words. I think that's the way you guys do it in physics, yeah? Way out of Mark. Or you can give it in component form. I don't care which way you do it. Just do it. But if you only put 6 root 3, see, that's where the problem is. Then that's only half the problem. Therefore, that would be minus 4. Okay, yeah.
How do you know the positive z is always this way and the negative z? Or is that just how it is?
But yes! X, y, is the positive z direction, it always comes like that. Otherwise, what the? Yeah, okay, that's just how it is. See, now notice how I put this vector in the xy plane. What if, like, tomorrow? I think I did this several years ago. I drew the same picture. Well, I drew it like this. It's in the YZ plane now. Is that gonna confuse you? Okay, these two vectors lie in the YZ plane on this wall right here. What would be the, okay, let me just ask you, let's just practice. What is the direction of A cross B? The shortest way to get from A to B is clockwise again, right? So you take out your screwdriver, turn it, it's gonna go that way, right? So it's like that. What direction is that? That's the negative x direction. Because the positive x-axis is coming this way, so negative x is the opposite way. Oh boy. Looks like I would... Okay, are you sure that's it? Yes, I copied out everything, Mr. Park. Okay, so how much time do I have? Okay, what can I give you to help you tomorrow? it says, mentions the word angle, you're gonna use the dot product thingy, okay? That's definitely on there. Then I'm gonna say, write the equation of the set of points, okay, you guys, I think you can do that. Yeah, I think you get them already. And then you're gonna have to convert from one to another, and one is gonna be spherical already, right? So, you sure we don't need to go over number 8? One more time. You guys got it? Okay. Okay, we're done then. We're done here. Draw the box. If I don't see the box tomorrow, I'm gonna be very upset. I need to see the box. Okay, the bell rings in 8 minutes. Okay, like I told you, some of you need big scores tomorrow, because I'm telling you right now, the next chapter is probably the hardest chapter of the whole year. That's because you gotta know everything. You gotta know all your graphs, you gotta know all your trig identities, you gotta know 2 and 3 dimensions, but you'll find that out.